In this video, we are going to focus on how do we get our 6 different trig values from a single point, such as 2, 2, or -5, 4. How do we find our sine, cosine, tangent, cosecant, secant, and cotangent from just a specific point? It's pretty simple, so let's get started. Let's say I have the point -3, 4, and I want to use that point to find the 6 trig values. Well, the very first thing I want to do is plot that point. Oops, so here we go. There's my coordinate plane. I've got -3 going back, +4 going up, and my point's going to be something like that. We're going to connect that point to the origin for one part, and then we are also going to connect that point to the x-axis. You always want to connect to the origin and the x-axis, regardless of where you are. And what we just have done is we've basically created a right triangle. I have a leg right here, I have the hypotenuse right here, and even though we didn't draw it out, I have my third leg right here. So this is our right triangle, and this is what we are going to use to find our 6 trig functions. But before we jump into the sine, cosine, and tangents of it all, we are going to have to figure out the lengths of our triangle's sides. Well, we went backwards 3, so the length of this side is -3. This part going up, after we went back 3, we went up 4, so this side is a +4. And then our hypotenuse, right over here, our hypotenuse can be found using the Pythagorean theorem, and it is always going to be positive. Pythagorean theorem always gives us a positive answer. So, if we remember our Pythagorean theorem, a squared plus b squared equals c squared. These 2 points are your a's and b's. Does not matter which one is which. If -3 can be the a, it can also be the b. So I'm just going to go in order. I've got -3 squared. If you use your calculator, make sure it's in parentheses, otherwise it will give you the wrong answer. Plus 4 squared equals c squared. That's going to give me 9 plus 16 equals c squared. 25 equals c squared. And then take our square roots, and c equals 5. So there is the length of our hypotenuse, 5 units. Now that we have all 3 sides of our triangle, we can find our sine, our cosine, and our tangent, and then we need to find their reciprocals. So, let's make my list. Sine of theta, cosine of theta, tangent of theta, and then, I'm going to write it down here, I guess, cosecant of theta, secant of theta, and cotangent of theta. Now, theta, that's our angle. The triangle has 3 angles. Which one do we want to use? We're always going to use the angle between the hypotenuse and the x-axis. So this is going to be my angle down here. Always going to use it between the hypotenuse and the x-axis. So, sine of theta, if this is my angle, that means 4 is the opposite side, -3 is the adjacent side, and 5 is the hypotenuse, which we've been calling it all along. So now as long as we remember our SOHCAHTOA, we can get our first 3, then we'll flip them and get our last 3. So sine is opposite over hypotenuse, so our sine is 4/5. Cosine is adjacent over hypotenuse, so our cosine is -3/5. And tangent is opposite over adjacent, so it is 4 over -3. And there we go. We have just found our first 3 trig functions. Cosecant is the reciprocal of what function? That's right, it is the reciprocal of sine, so this is 5 over 4. Secant is the reciprocal of cosine, so this is 5 over -3. And cotangent is the reciprocal of tangent, so we've got -3 over 4. And there we go. We have just found the trig values from a single point. Let's recap what we did. Our point was originally -3, 4. Okay, so we plotted that point first. We connected that point to the origin, and then we also connected that point straight down to the x-axis. That gave us a triangle shape. We then found the lengths of the legs, which is really the x and y components of our point, -3 and 4. We used the Pythagorean theorem to find the hypotenuse. And once we had the hypotenuse, we were able to use our SOHCAHTOA to get our 3 original trig functions, and then we flipped them upside down to get our 3 reciprocals. And there we have it. Hopefully this video helps, and good luck.